Today we're going to be talking about division properties of exponents, and we're going to start with the quotient of powers property. If a is a non-zero real number and m and n are integers, then a to the m over a to the n is equal to a to the m minus n. So basically what we're doing is we're subtracting the exponents when the bases are the same and we're dividing. So if we have 2 to the 9th over 2 to the 7th, that is equal to 2 to the 9 minus 7. So in other words, that is 2 to the 2nd power, which is 4. Now if we have y to the 1st, because that is really what the exponent is on the y, over y to the 4th, we are going to have y to the 1 minus 4, or in other words, y to the negative 3 power. And as you know, we can't leave a negative exponent in our answer, so it moves to the denominator, and we have 1 over y to the positive 3 power. 1 over y to the 3rd. Next, let's take a look at m to the 5th, n to the 4th, over m to the 5th raised to the 2nd power times n. Now, first thing we want to do is let's simplify this m to the 5th raised to the 2nd power. So multiply the 5 and the 2 together, and we get m to the 10th. Now we can put an n to the 1st here. In the numerator, we still have m to the 5th, n to the 4th. Now let's subtract our exponents on the terms with the like bases in the numerator and denominator. So m to the 5th over m to the 10th gives you m to the negative 5. Always start by putting your answer in the numerator. N to the 4th over n to the 1st gives you n to the 3rd. Now we have a negative exponent, so it's going to have to move to the denominator. So down below it becomes m to the 5th. So we have n to the 3rd over m to the 5th. Next, let's say we have 3 to the 5th times 2 to the 4th times 4 to the 3rd over 3 to the 4th times 2 to the 2nd times 4 to the 6th. Just subtract your exponents for the like bases. So 3 to the 5th over 3 to the 4th. 5 minus 4 is 1, so 3 to the 1st. 2 to the 4th over 2 to the 2nd. 4 minus 2 is 2, so we have 2 to the 2nd power. 4 to the 3rd over 4 to the 6th. 3 minus 6 is negative 3, so times 4 to the negative 3rd power. Anything with a negative exponent gets moved to the denominator, so we have 4 to the 3rd in the denominator, and we have 3. 3 to the 1st is just 3. 2 to the 2nd is just 4. So we have 3 times 4. So we have, now at this point, if you wanted to, you could, before you simplify 3 times 4, put a 1 on the 4, and notice we can do this all again. We've got 4 in the numerator, 1 in the denominator, so let's subtract the exponents. 1 minus 3 gives you 4 to the negative 2. So I have 3 times 4 to the negative 2. Take that part with the negative exponent and move it to the denominator. So we have 4 to the 2nd in the denominator and 3 in the numerator. Well, 3 over 4 to the 2nd simplifies as 3 over 16. So 3/16. Okay, next, 2 to the 7th over 2 to the 2nd. Bases are the same, so just subtract the exponent. 7 minus 2 is 5. 2 to the 5th gives us 32. Next, x to the 4th over x to the 3rd. Subtract the exponents. 4 minus 3 gives you 1. X to the 1st is just x. Moving right along. D to the 4th times e to the 3rd over, in parentheses, de squared. So let's actually simplify the denominator first. de squared will be d to the 2nd, e to the 2nd. And the numerator remains the same, d to the 4th, e to the 3rd. Take the exponents on the like bases and subtract them. So d to the 4th over d to the 2nd gives you d to the 2nd. 4 minus 2 is 2. E to the third over e to the second. 3 minus 2 is 1, so it's e to the first. And you can just write that as d squared e. One last one on this page. Let's take, and we've got 3 times 4 to the third times 5 to the fifth, and in the numerator, let's just put a 1 on that first 3 for the exponent. And that's all divided by 3 to the second times 4 to the fourth times 5 to the third. Let's subtract the exponents on the like bases. So 1 minus 2 gives you negative 1. We have 3 to the negative 1. For the 4s, 3 minus 4 gives you negative 1, so you have times 4 to the negative 1. 5 to the fifth over 5 to the third, 5 minus 3 gives you 2, so 5 to the second. Let's move everything. These are all being multiplied together, by the way. Don't forget that. Move everything with a negative exponent to the denominator. So we've got just 3, or 3 to the first, times 4 to the first. In the numerator, we've got 5 to the second. Well, 3 to the first times 4 to the first. That's just like having 3 times 4, which is 12. So we're going to have 12 in the denominator. And 5 to the second in the numerator becomes 25. So we have 25 over 12. Now let's move on to the next page. We want to simplify and write the answer in scientific notation. For this particular problem, 3 times 10 to the 10th divided by 6 times 10 to the 6th. So let's write this out as a fraction. Okay. And you know what? Let's go ahead and divide the 3 and the 6 out. 3 divided by 6, well, that gives you a half, or 0.5. And since we're going to write this in scientific notation, let's get the decimal in there. 10 to the 10th over 10 to the 6th. The rule that we just learned told us to subtract the exponents when the bases were the same. So that's the same as having times 10 to the 4th. 10 minus 6 is 4. Now let's think about what that means. That actually, if you were to write that in standard form, would mean to take that 0.5 and move that decimal point 4 places to the right. So that would really give you 5,000. But we want to write that in scientific notation. Well, think about how you do that. You say 5. We have to have the first number be either be greater than or equal to 1, or I'm sorry, it has to be greater than or equal to 1, but less than 10. So 5 would be your first number. And how would we get 5,000? 5 times 10 to what power? There are 3 zeros following that 5, so it would be 3. So 5 times 10 to the third is how we would write that in scientific notation. Next, we have 3.3 times 10 to the 6th divided by 3 times 10 to the 8th. Again, write this as a fraction. We have 3.3 divided by 3. Well, that gives you 1.1. 10 to the 6th divided by 10 to the 8th. 6 minus 8 gives you negative 2. So that's times 10 to the negative 2. Remember, you can leave negative exponents in scientific notation. In fact, many times you have to. So this is our answer. 1.1 times 10 to the negative second. Okay, so moving on. Positive power of a quotient property. If a and b are non-zero real numbers and n is a positive integer, then a over b to the nth power is equal to a to the n over b to the n. You're just basically applying the exponent to both the numerator and the denominator. So let's try this out. 4/7 raised to the second power means you have 4 to the second over 7 to the second. Well, that simplifies to 16 over 49. Next, 3d to the second over ef raised to the fourth power. We're going to raise everything inside to the fourth power. 3 to the fourth power. d to the second raised to the fourth power, remember that means to multiply those exponents. So we're going to have d to the 8th, we have e to the 4th, and f to the 4th. And about the only thing we can simplify here is actually 3 to the 4th power, which gives us 81. So we have 81 d to the 8th over e to the 4th, f to the 4th. Moving on, we have 2x to the 3rd over xy in parentheses cubed, all raised to the 2nd power. Let's simplify what is in the denominator first. Xy all raised to the 3rd power means we have x cubed, y cubed. And our numerator is the same, 2x cubed, but this whole quantity is raised to the 2nd power. So let's go ahead and do that. Now, you might notice something first. You notice how we have x to the 3rd in the numerator and x to the 3rd in the denominator? If we have identical quantities like that, we can just cancel them out. So really what we have is 2 over y to the 3rd raised, all of that raised to the 2nd power. So now let's do that. We get 2 to the 2nd. I was going to jump ahead and say 4, but let me write it out step by step. 2 to the 2nd over y to the 6th. Okay? And 2 to the 2nd is just 4 over y to the 6th. So let's move on to this next one here. 2 to the 3rd over 3 to the 2nd, all raised to the 2nd power. So raise everything to that 2nd power. We multiply the exponents. So we have 2 to the 6th. And in the denominator, 3 to the 4th, because we multiply 2 times 2 to get 4. So 2 to the 6th gives us 64, and 3 to the 4th gives us 81. And the last problem on this particular page, we have ab to the 4th raised to the 5th power, and I'm sorry, ab to the 4th over c to the 2nd, d to the 3rd, all raised to the 5th power. So raise everything inside to the 5th power. So we have a to the 5th, multiply the 4 and the 5, so we get b to the 20th. Make that look a little bit better. b to the 20th over c to the 10th. 5 times 2 gives us 10. d to the 15th. Okay, so a to the 5th, b to the 20th, over c to the 10th, d to the 15th. Moving on to the next page. Let's take a look. We have 3/4 to the negative 3rd power. That means we have 3 to the negative 3 over 4 to the negative 3. The exponents are both negative, so these two items need to switch places. So we have 4 to the 3rd on top in the numerator, 3 to the 3rd on the bottom in the denominator. So we get 64 over 27. Next, 2 to the negative 2 power is what we're going to get when we raise everything to the negative 2nd power. X to the negative 4, y to the negative 6. Everything has a negative exponent, so everything in the denominator moves to the numerator and vice versa. So we have y to the 6 over 2 to the 2nd, x to the 4th. Simplifying this, we have y to the 6th over 4, x to the 4th. The very last problem